Hey, y'all, like I said, this is our test for review. So I'll be doing them by hand, but I'm gonna show you how to put some of these on the computer for the first three, especially because they're all graphing. So for number one, they want us to graph y equals 1/6 to the x power. Now, on this one, they give you 4 pictures to choose from. So I'm gonna show you how I would do this on the calculator just to get an actual idea of what it's going to look like. So I'm gonna go to my calculator. I'm gonna go to y equals. Now, when you put this in, you got to put that fraction in parentheses since you got an exponent following it. So you do parentheses 1 divided by 6, close parentheses, and then hit your exponent and put in your x. So now if we graph that, we'll get a general idea of what it's going to look like. They sort of see it come down from the left, and it's hard to tell, but that's getting closer to the x-axis as it goes out towards infinity. So let me show you our 4 choices. So you got A, B, C, or D. So ours came down and then started trying to hug that x-axis. So for us, we would pick D on that one, okay? Now, if you're doing these by hand, you got your X and Y axis. I'm just going to go out about 5 on it. So y'all, if you're doing it by hand, I'll just make a little table up, X, Y table. I would use 0 for this. Because remember, anything to the 0 power equals 1. So this is going to go right through here at 0, 1. Then I'm just going to pick another number. I'm going to pick a 1. So if you put a 1 in for the x, 1/6 to the first power would be 1/6. So notice over here at 1, it's at 1/6. So see, it's getting closer to the x-axis to the right. So if you want to see what's happening on this side, I'm going to try exponent of -1. So if you put a -1 in for that exponent, to make the exponent positive, you flip the fraction. So that'll become a 6/1 to the first power. So that's what? 6 divided by 1 is 6, and 6 to the first power is 6. So over here at -1, you're up here at 6. So we can tell now the left side's coming down, going through that 0, 1, and then it's just going to try to hug the x-axis as it goes towards infinity. So we picked D on that. I think it was D. Let me see. But yeah, D's the one that looked like it was coming down and then trying to hug that x-axis. All right, y'all, number 2 here, sketch the graph and then describe how it can be obtained from the graph of a basic function. So our base is 2, and then they're adding 3 to the x. Anything you add or subtract from the x is going to move it left or right. If it's positive, it's going to move left. If it's negative, it's going to move right. So that is positive, so it's going to move left. So I would pick A that shows it moving to the left. And in the box, you need to put your base, which is the 2. So you would put 2 in there, shift it left. Now it's going to say next. Whoops, I got to finish it up, don't I? Oh, so I got to graph it real quick. So click on enlarge graphs. Now remember, exponential graph is going to be that exponential tool. second row, second item. So click that and just click the graph anywhere. It's going to put the graph right where it wants it. So we're going to come down here. We did a horizontal. We went left 3. So we would move our horizontal to -3. Now, y'all don't forget down here in the bottom where it says base, you got to change it from an E to a 2, which was what my base was. Now, once you do that, save that and move on to the next question. And y'all, this is doing the same thing. But now, they want me to describe how it can be obtained. So I'm going to start with the graph of y equals 2 to the x, because that's my base up here. Now the +5 is being added to the x. So that means I'm actually going to go left 5 units. So you would click left. And then that -4 at the end, anytime we add or subtract from the end, that's going to be up or down. So since you're subtracting 4, you're going to move it down 4 units. And then click to enlarge graph. So remember, exponential tool again. So click that, click anywhere on the graph. So y'all, we had 2 moves on this, and we got to do horizontal, left 5, or vertical. We got to move to -4 because we went down 4. And then remember, down here in the bottom, change that base from a little e. Let's see, mine's a 2 again. So put a 2 in for the base and then save that. Okay, y'all. So that's how you're going to do those first 3 on that math lab. So now I'm going to go back to my paper and I'm going to move on to number 4 now. So the first 3 are graphing, and I think that's the only graphs on this test. Okay. All right. So starting number 4. This one says on Melissa's 6th birthday, so the 6th birthday, she gets a $5,000 CD that earns 4% interest, compounded semi-annually. So then it says it matures on her 10th birthday. So what they want to know, if it matures on her 10th birthday, how much money is available? And y'all, I gave y'all a formula for this one, which was A of T. Remember, A stands for the amount of money you have based on how many years have gone by. That's what T is for the time. So this equals your principal balance times parenthesis 1 plus R divided by N, all raised to the N times T exponent. P is your principal balance or your starting amount, which will be the 5,000. R is your interest, which is 4%. But remember, we got to turn 4% into a decimal. So you got to move the decimal left twice. So for this one, we're going to have to add a 0 and make that a 0.04. N is the number of compounds per year. So y'all, what would semi-annually be? How many compounds would that be for a year? All right, so I'm trying to pull the chat up. Oh, perfect. Y'all got 2 on that. Good job. So N for us will be 2 on this one. Now what I need to know is what is our time? So how many years have passed for our time? So that's 4. Good job, because you got her 10th birthday minus her 6th birthday. So good job. That's 4 years. So we'll just plug everything into this, and then we're going to hit it on the calculator. Okay. So P was 5,000. 1 plus our 0.04 divided by 2. And then my exponent would be the 2 times 4. All right, y'all, so let me get my calculator going on here and we will punch that in and see what we get. All right, so we had 5,000 times parentheses 1 plus 0.04 divided by 2, close parentheses, and then my exponent was what, 2 times 4, which would be an 8. All right, y'all, so hit enter. Now we're rounding this to the nearest cents, so that's 2 decimal places. So I got 5858 point. Oh, so my 9's got a 6 after it, so the 9's changing. So that's going to be definitely a 0.30. Good job. You know, that's your trick on that one, is just getting that formula. So this is the formula you want for this part of this problem. So make sure you got that formula for number 4, okay? All right, number 5, find the log. They're giving me log base 10 of 0.01. So y'all, here's the thing. In since that's a log base 10, you can use the log that's on front of your calculator. So let me pull my calculator up here. Right here by the 7, that log button you see, that is a log base 10. So just hit the log button and then put in 0.01, hit enter, and we get a -2. Okay, so anytime you got a log base 10, you're going to use the log button on the front. If it's a log base E, then you use the LN button. All other logs, we have to use that log base that's in the math, okay? So if you wanted to use that one on that, you would hit math, arrow down to log base. Whoops, passed it up. All right, so go to log base and hit enter. And then you can actually put in the 10 if you wanted to. And then the 0.01, hit enter. You're still going to get -2. All right, number 6 was another log. Find the log again. They're giving us log base 6 of 6 to the 4th. So I'll show you how I would punch that in if you don't remember how to do this one on the calculator. But y'all, anytime you got a base that matches a result raised to an exponent, if that base matches the base of the result, then the answer is going to be that 4 every time, always the exponent. But I'll show you how I would punch that in on that calculator. I would actually use my log base. So I'll hit math, arrow down to log base, hit enter, put in my 6, and then arrow over, and then put in 6 with an exponent of 4. So everything's got to be inside the parentheses when you do it on the log base. When you hit enter, we're going to get 4. So let me ask y'all, do all y'all have the newer calculators like this TI-84 Plus? Does anyone have the older calculators? Because I can show you how to do it on that also. All right, so y'all have plus, good job. All right, so that will just equal that exponent. Remember, if the base matches the result to an exponent, the answer is always going to be that exponent, okay? All right, number 7, find log. So 7, I got log base 16 of a 4. All right, so you can knock that out on the calculator. So we'll go to that. So for that one, you definitely got to go to log base. So hit math and arrow down to log base. All right, hit enter. That was a base of 16. That result was a 4. So now when we hit the answer, we get a 0.5. Now, y'all, it don't want 0.5 for the answer. It wants that to be a fraction. So I need y'all to hit math and then enter twice. And good job, you're going to get a 1/2. So it's not too bad. It's a lot of calculator on this test. 8 is the same thing. Find a log. Y'all, so I got log base 39 of a 1. Now you shouldn't use the calculator on this. There's only one exponent that can turn that 39 into a 1. So what would that be? Oh, good job. It is definitely a 0. So y'all, I don't care what your base is. If that results a 1, then that answer has to be the exponent of a 0. All right, now it sort of changes tune. For 9 and 10, we're going to convert to a logarithmic equation. So they just want us to rewrite these, okay? So 9, I got 10 to the 6th equals 1 million. So to convert to a log equation, you're going to have that log written down. The base is the 10. The result is the 1 million. And that equals the exponent of a 6. And y'all, 10 is going to do the same thing. The only thing, number 9 is all numbers, so you can figure out base 10 to the exponent of 6 will equal 1 million. But on 10, they just gave us some letters here. They gave me e to the negative 5 equals little p. And y'all, here's one thing also on these kind of problems. If they use a small p, you got to use a small p. If they use a capital P, you got to use a capital P, okay? All right, so let me write this out. We know this is going to be a log. The base is the e. The result is the p, and that equals the exponent, which is a negative 5. And y'all, here's the thing on this one. Since this is a log base e, they use the ln for that. Because remember, ln is a log base e. So ln of p equals negative 5. Okay. So then these were converting to logs. 11 and 12, we're going to convert to exponential. All right, y'all, 11 has log base 3 of 27 equals 3. So you come down with your base, which is a 3. The exponent is the 3, and that's going to equal that result of 27. And y'all, that's true, right? 3 to the 3rd power, 3 times 3 times 3 is 27. So that you can sort of check out also. All right, so 12, we're going to convert to exponential equation. This one has a log base little n of a capital R equals a negative small y. So notice, they gave you one with numbers, one with letters that you couldn't check, one with numbers, one with letters you can't check. So they just want to make sure you got the idea down. So the base is the n, exponent is the negative y. That's going to equal that result of capital R. Okay, you also just follow them patterns on those. 13 wants you to use a calculator. And we're going to round this out 4 decimal places. So this is the LN of 535.4. So I'll let y'all play with that and round me out 4 decimal places, okay? And so I would use that LN that's on the front of my calculator for that one. So let's see. 6.2380. I think y'all perfect. So 6.2830. Good job. Now let's see, 14. 14 says find a log using change of base. But here's the thing. If you have the TI-84 plus, use your log base on that one, okay? Because you can punch in log base, it'll punch this in just like it looks. And they want me to figure out log base 4 of 30. So what change of base is for the older calculators to do these problems. So for the older calculators, you would have to do a log 30 divided by a log of 4. Newer ones, I would hit math, go down to log base, put in my 4, put in my 30, hit enter, and be done. But no matter which way you do this, you will get the same answer. So any of y'all got this one rounded out to 4 decimal places. $2.4534, perfect. Hey, y'all, so this is how you would do those on the up here. If you didn't have a calculator with the log base on it, you would have to do the log 4 divided by log 16. So that's what this change of base is. It's allowing you to do these on your yeah, that'll work too, doing that math alpha math, okay? All right, y'all, let's see. What's that put me on? 15. So for 15, they want us to express as a sum. So that means they're giving me a product. They're giving me a log base 18 of 18 times 324. So we express products as sums, and if it was a quotient, that would be a difference like subtraction. And y'all, all we got to do to this is distribute the log 18 to both factors and put a plus sign in the middle. So we'll have a log base 18 of 18 plus a log base 18 of 324. It's now written as a sum, and we're done. 16, express as a product. So let's see, they're giving me a log base P of Z to the 19. Now, when they say express as a product, there's only one thing they're wanting us to do, y'all. They're wanting us to take this exponent and bring it down to the front. So that instead of it being an exponent, it's now a product. It'll be the 19 times log base P of Z. Y'all, we had to do that a lot last week, bring them exponents down, okay? So that's what they're wanting us to do on that. Do y'all have questions on this first half? All right, if y'all ready to go. So let's see, 17, rewrite as sums or differences. All right, y'all, we got a log base D of X to the 8th, Y to the 9th, and a Z. And if you notice, these are all being multiplied, so we're only going to have sums on this. We won't have no differences because it's not being any kind of division going on, okay? So we're going to distribute the log D to all three of these factors and put them together as addition. So log base D of X to the 8th plus log base D of Y to the 9th plus log base D of our Z. Now, only one more thing to do. And that is, if it's got an exponent, we got to bring the exponents down to the front of those logs. So this one will give me 8 times log D of X. This one will give me 9 times log D of Y. And then the last one was already good. So let's bring down the log base D of Z. All right, so it's now rewritten as sums, and we're done. Now, y'all, this one, they don't give you choices on, but this number 18, they're going to give you A, B, C, D choices on 18. So this one wants me to express as sums or differences. Basically the same thing as 17, except this time we will have some subtraction going on. So we got a log base B of P squared Q to the 6th over M to the 4th B to the 7th. Now here's the thing. If it's on top, it'll be addition. If it's on the bottom, it's going to be subtracted. I'm going to distribute the log B to all 4 of these factors. So remember, if it's on top, it's positive. So you got a log B of P squared plus a log B of Q to the 6th. Now, the 2 factors from the bottom are going to be subtracted. So minus log B of M to the 4th minus log B of B to the 7th. And y'all, guess what? My last move, I'm going to move all these exponents down to the front except for one. I'm not going to move this exponent to the front yet. So here's my question. Log base B of B to the 7th, what does that equal in the long run? Or you're close, but remember, if the base of a logarithm, how about that? I want that 7. Good job. If the base matches the result to an exponent, then remember the answer is always that exponent. But we're going to go with that 7 on that there. So we'll have everything brought down, and then we'll put a 7 there. So this will give me 2 log b of p plus a 6 log b of q minus 4 log b of m minus that 7. And y'all notice here on the test, they'll give you all them answers. Be careful of this kind of answer where they put the 2 in the wrong spot. And then if you notice, this one didn't simplify that one, and that didn't simplify. But be careful, because you see that 7 here and that 7 here, but be careful, they putting the numbers in the wrong spot. It should be in the front of the log instead of by the actual letters, okay? So y'all be careful of that on there. All right, 19, simplify. So it looks like 19 and 20 are both going to be simplifying type problems. One uses ln and one uses logs. So this one has ln of x squared plus 6x plus 8 minus the ln of x plus 4. So y'all, your first step on this would be write this as a single logarithm. So remember, since it's being subtracted, it's going to look like division. So bring that ln. The top will be the x squared plus 6x plus 8. The bottom's going to be the x plus 4. And y'all, here's the trick on this one. I need to simplify this. And the only way to simplify this is to use some factoring on the top. The bottom, I can't do nothing to. That's just the x plus 4. So what we got to work on is that top. We're going to factor the top to see if anything's going to cancel. So we got an x squared. That's going to be an x and an x. That 8 is positive. So both of these will be positive like the 6. So I guess what I'm looking for are factors of 8. That'll give me a 6. And I'll tell you a trick. You got an x plus 4 on the bottom. If it's going to simplify, one of these has to be an x plus 4. So let's see, 8 can be 4 times 2, which will add to get 6. So I'm going to use my 4 and my 2. So good job. I think y'all's chat is sort of delaying on me a little bit. I've been seeing my computer sort of flicker a little bit, so we might be having a little bit of internet issues. But y'all watch this. X plus 4 is cancel. So the final answer is ln of x plus 2. Now here's the thing. You must keep the parentheses on this one. Because that whole factor is being affected by that ln. If you just put x plus 2 without parentheses, it will mark that wrong, okay? So make sure you keep that in parentheses. Now, number 20 is the same thing. They want us to simplify. This time we're using a log. This one has a log of x squared plus 7x plus 6 minus the log of x squared minus 1. So write it as a single log first. So the top is the x squared plus 7x plus 6. The bottom is the x squared minus 1. And now both of these have x squareds, so both of these will factor. So we'll have parentheses on top, parentheses on the bottom. So y'all, that's an x squared, so that's going to be an x and an x. That 6 is positive, so both of these will be positive like the 7. All right, y'all, so factors of 6 that add to get a 7. Now, good job. The bottom has an x squared, so that's going to be an x and an x. And this is what we call the difference of perfect squares. So since that last number is negative, this would be a positive and a negative. And then to get the two numbers, you're just taking the square root of your last number. So square root of 1 is 1, so both of these would be 1 and 1. So if you had a 4 here, that'd be plus 2 minus 2. 9 would be plus 3 minus 3. That's always going to be perfect squares on the bottom for this number 18, okay? Because now notice the x plus 1's cancel. So my final answer will be a log of an x plus 6 over x minus 1. Now on this one, you don't need to keep the parentheses around it because you got a single fraction here, okay? But notice the difference. This one didn't have a fraction, so we had to keep the parentheses. All right, y'all. So then we started having some equations. So let's move on to what, number 21. So 21 just says solve. Actually, 21, 22. So the next four are going to be equations that we're solving, okay? So 21, they got 2 to the x equals 3. So we sort of wish that we could rewrite that 3 using a base of 2, but we cannot rewrite this one. So since I cannot rewrite both sides using the same base, what I got to do is take the log of both sides. So the log of 2 to the x will equal log of a 3. And y'all, the only reason we took a log of that is for one purpose. And that purpose was so I could bring that x down and write that as a product. So I'll have an x times log of 2 equals the log of 3. All right, now solving for x, we divide both sides by log 2. So x log 2 divided by log 2 will equal my log 3 divided by my log 2. Now doing this on the calculator, you gotta close these parentheses, okay? So these logs will cancel. So x, round me out 4 decimal places. So let's see, we would go to our calculator. So I had a log of what, 3? Those parentheses divide by the log of 2. Close those parentheses. And remember, we're rounding out about 4 decimal places. So let's see, we get 1.58. So let me see what I got left. 496. So that 6 is rounding me up. So that's going to be a 5850. Y'all, let me show y'all a trick. Watch this. If you want to round 4 decimal places, watch this. I'm going to hit the mode button. And I'm going to click down right now while I'm on float. That means it'll give me all the decimals. But I'm going to arrow over here to 4. When I click on that 4, that is now going to round me 4 decimal places. So watch what happens. So watch this. This answer I just punched, if I now hit enter, I now get it rounded off to 4 decimal places. So if you want that calculator to round for you, hit mode and go down there and change that from float to 4, and it'll give you 4 decimal places every time. All right, y'all, 22. Solve for x. So I got a log base 2 of 5x minus 1 equals 1. So for exponential, I change the logs. Logs, I rewrite them as exponential. So I got a base of 2, exponent of 1. That's going to equal the result of a 5x minus 1. And y'all, 2 to the first is 2. So now you got 2 equals 5x minus 1. So we'll solve this. We're going to add the 1 to both sides and then divide by that 5. So let me add 1. So I got 3 equals 5x. And then, like I said, divide by 5 on both sides. So that cancels, giving me my x. Can't do nothing with that 3/5. So I'm going to leave that as a 3/5. All right, y'all, this one says solve. I got log base 5 of t plus 27 minus log base 5 of t plus 7 is going to equal log base 5 of a t. So y'all, here's the trick on this one. You got 2 logs on this side. We need to turn those 2 logs into a single log. So that's going to be a log base 5. Now remember, it's being subtracted, so it's going to look like a quotient. The positive part, the t plus 27 goes to the top. The stuff being subtracted, the t plus 7 goes to the bottom. That's going to equal my log base 5 of a t. Now, this log base matches this log base on that side. So since these log bases match, that means that the t plus 27 over t plus 7, this result has to equal this result of a t. All right, y'all, so let me show you what I did to this. I put a 1 under that. I did some cross multiplying on this when I did it. So this top times that bottom. So t plus 27 times 1 is t plus 27. Then you take the bottom and multiply by that top. So t times t is t squared plus 7 times t is 7t. All right, so let me show you what I got to do. I got to get everything on one side equal to 0 because of that t squared. So what I'm going to do is subtract the t from both sides and then subtract 27 from both sides. So I'm going to pull that up here. So doing that, this left side will be 0. I got a t squared. 7t minus that 1t leaves me 6t. And then at the end is my negative 27. So y'all, at this point, you can hit that with your quad program. I'm going to factor it real quick. So I got a t squared. That'll be a t and a t. That's negative. So one will be positive, one will be negative. Okay, y'all, I need factors of 27 that will subtract and give me a 6. Ooh, my chance running slow, but that's perfect. 9 positive, 3 negative. All right, now remember, go t plus 9 equals 0, t minus 3 equals 0. So we got to get them factors, signs changed to get the actual answers. So it looks like I'm going to get a negative 9 and a positive 3. So what would y'all put as your answer? All right, don't see my chat moving. So remember one thing. When I'm dealing with logarithmic equations, I cannot take the log of these negative numbers. So good job. It's only going to be the t equals 3. Any negative answers you get on these logs, you might as well throw it away. Because those are the ones that do not exist when you try to put them numbers in for them logs, okay? So the only answer is going to be the positive values y'all get for number 23, okay? Now let me turn this paper over. It's getting a little curvy. All right, same thing for 24. Solve. So now they're giving me log base 3 of x plus 4 plus log base 3 of x minus 4. All that is equal to 2. So now the difference on this one, okay, someone said go back one moment. So let me. All right, so I'm back on 23, okay? Now, we'll say this, y'all. On this problem, at this point, if you'd have used your quad 1, 6, negative 27, it would have actually gave you the negative 9 and 3. So still throw that negative answer out and keep that positive in the tank. All right, okay, ready to go. All right, now the difference on this one and the last one I just did, 23, it does not have a log on the right side. So I'm not going to be able to use that log base equal on each side property, okay? So we'll do this one that's a little bit different than that one. But the first thing we got to do is rewrite these two logs as a single log. These ones are being added. So since they're being added, it's going to be a product when we rewrite it. And all that's going to equal that too. And y'all, I would probably go one more step on that. And I would probably FOIL this out real quick. So x times x is an x squared. 4 times negative 4 is a negative 16. All that equal to 2. Remember, I shortcut FOIL that one because these are conjugate pairs. X plus 4, x minus 4. Anytime you got conjugate pairs, you can do that shortcut, okay? All right, now what I would do to this is rewrite it as exponential. So my base is 3, my exponent is 2, and that's going to equal the result of an x squared minus 16. All right, so the first thing I would probably do is figure out what 3 squared is. 3 times 3 is make that a 9. That's going to equal x squared minus 16. And y'all, the quickest way to solve this, we don't even have to factor this because we don't have that x term. So what I would do here was add 16 to both sides. So I get 25 equals x squared. And then we're going to do square roots to both sides. So square root of x squared would be x. Square root of 25 would be a positive or negative 5. If y'all remember. I cannot keep that negative answer again. So that my only answer would be positive 5. So 23 and 24, you're going to have a little bit of solving to do, and you're going to have to probably either factor them or use the square root on number 24. Remember, on those two problems that are logs, get rid of them negative answers. All righty, so this one says, so this would be stuff from 9-7 for this last problem. We got $13,314 is invested at 6.1% interest, compounded continuously. So they want me to find the exponential function that describes the amount after t years. That was A. And then B, what is the balance after 1 year, 2 years, 5 years, 10 years? So I'll probably use my value function on the calculator for that. And then C, what is the doubling time? So remember, these formulas are P of T equals P initial times E to the K times T. K is my interest rate or my growth rate, which is that 6.1%. PO, which is the initial principal, is the 13,314. And then T would be time in years. So what they want us to do on this one for part A is we'll have P of T equals our initial amount, 13,314 times E. Remember, K, that's percent. Can y'all turn that 6.1% into a decimal for me? Point 061, I'll take that. So 0.061 times T. So now that is my function. If I know what T is, I can figure out how much money is in that bank. Now for part B, they wanted us to figure out when T equals 1, what we'll have. When T equals 2, what will we have? When T equals 5, what will we have? And then when T equals 10, what will we have? So y'all, let me show you how I did that on my calculator. Now you can do this 4 different times, just put 1 in for the T, see what you get. And I went around these 2 decimal places. But y'all, the easiest thing, let me show you, is on that calculator like we looked at. So let me pull up my calculator. I'm going to go to y equals and put that in my y equals. So let me clear out that other graph. So we got 13,314. And then I'm going to use the second LN so I can get that E with the X. So second LN, there's my E. And then I got 0.061. Now we can't use the T here, but we can use our X. So put it into Y1 using the X. And remember, we don't even care about the graph. We just want to use the value function. So if we hit second and then the trace button, which is the 4th one on the top, it brings up this list. Value is the number 1. So hit enter. And then down here it says, well, what's your X? So my first X was 1. So I'm going to put a 1 in and hit enter. So I now have, what's that? 14,151.4. So the 3 has a 6 after it. So I'm going to turn that 3 into a 4. And then y'all would do the same thing. Second trace, value, enter. This time I had a T was 2. So hit a 2, enter. And now I got 15,041.5. Let's see, the 4 has a 6, so it's going to turn into a 5. All right, next. Second trace, enter for value. Next was a 5 for my T, so I hit enter on 5. And now I'm getting 18,062.1. So that 0 has a 5, so it's going to turn into a 1. And then one more time, second trace, enter on value. This time T was 10. And y'all notice it's got to go up over time because this was an interest rate problem. So now I'm at what? $24,503.5. Let's see, zero has a 4 after it, so zero stays a zero. All right, y'all. So now let's see what they wanted on part C. So part C just wanted to know what is the doubling time. So this is the formula to find what you have at any time t. Doubling time was the one I gave you, was the capital T equals the ln of 2 divided by K. Well, K we figured out that was that 0.061, right? The same as the interest rate, that's your K. So this will equal the ln of 2 divided by 0.061. Also remember, when you put in that ln2, close those parentheses. All right, y'all, so let me find my calculator real quick. All right, so quit that page. I had what, an ln of 2. So ln of 2, close parentheses, divided by 0.061. And guess what? We started with 13,000. Doubling that would be about 26,000. So 10 years was getting close when we did it, because 10 years we had 24,000, but that's not double yet. But it's got to be over those 10 years. So y'all, when I hit enter, and let's see what they want me to do. Round 1 decimal place. So that'll be what, 11 point. So the 3 has a 6 after it. So the 3 will turn into a 4. So the double's in 11.4 years. Oh, y'all, that was number 25. So that was all of that one. So let me go back to our share. All right, so remember this formula for your double time. This formula for your amount at any time t, okay? So that's the 25 questions that you're going to see on test 4. So remember, 23 and 24, watch out for those negative answers, okay? All right, y'all, so questions on this. All right, so test 4 is now open. It's not due to the end of the term. I think I got it due for the 11th, which is the last day for anything to be done, okay? So your final exam, all the tests, all the homework got to be done by December 11th. Also, y'all, anytime this week or next week, there's a support quiz in there. So Kira, I'm taking that out because we did matrices way back when we did the systems of equations. And since I sort of showed y'all the matrices then, we don't have to do the 10.2. So I'm going to eliminate it from your homework, okay? Now there is something you got to do before the end of the year, and it's a support assessment quiz. It does not count against your grade at all. It's just a sort of a assessment we do for the support side of the class. So it's like 10 little questions, like some factoring and stuff like that. But that support quiz does not affect our grades at all, okay? So here's the thing, if you missed any tests, you need to email me to get them tests open so you can take them, okay? Now, I'll replace one low test with the final exam score if it's higher than those low tests. You should do pretty good on the final because it's multiple choice. Okay. And then I owe some of y'all bonus. I forgot to take my stuff over to break home, so I'll be adding those bonuses this afternoon. And I had a few of y'all in here that actually did it. So I'll get them added today. So y'all, here's the thing. Wednesday, we're going to start studying for the final exam. So I should be able to get most of them 25 done. Whatever we don't get done Wednesday, we'll finish up that next Monday. So next Monday officially will be our last day of doing any webinars, okay?